When designing a software application, you don't need to reinvent the wheel. Over decades, software engineers have created proven architectural patterns that help us build systems that are maintainable, scalable, testable, and easier to evolve. But the important question is not, which architecture is the best? The better question is, which architecture best fits the business problem? Layered architecture is one of the most common patterns used in enterprise applications. The system is divided into clear responsibilities. Presentation handles user interaction. Business logic manages application rules. Data access communicates with databases. The database stores information. Advantages. Benefits include simple structure, clear separation of responsibilities, easy onboarding for developers, straightforward maintenance. Examples. Commonly used for ERP systems, CRM applications, HR platforms, internal business applications. Trade-off. However, as applications grow, layers can become tightly connected. Small changes may require modifications across multiple layers, slowing development. Clean architecture focuses on protecting business logic from external dependencies. The core business rules should not depend on frameworks, databases, user interfaces, external services. Benefits. This provides better testability, framework independence, easier long-term maintenance. Best suited for complex business applications and enterprise systems with long life cycles. Trade-off. The challenge is that it requires more upfront design thinking and discipline. Microservices architecture breaks an application into smaller, independently deployable services. Each service focuses on a specific business capability. Benefits. Independent deployment, team autonomy, individual service scaling. Great for large platforms, multiple development teams, systems with different scaling requirements. Trade-off. Microservices also introduce distributed system challenges. Service communication, monitoring, distributed transactions, infrastructure management. In event-driven architecture, services communicate through events instead of direct calls. For example, an order is created. A payment event is triggered. Inventory is updated. A notification is sent. Common technologies. Apache Kafka, RabbitMQ, Azure Service Bus, AWS EventBridge. Benefits. Loose coupling, real-time processing, high scalability. Trade-off. Managing event flows, debugging, and eventual consistency can become challenging. CQRS separates operations that change data from operations that read data. Commands handle updates. Queries handle retrieving information. Benefits. Improved performance, independent scaling, optimized complex workflows. Great for high-volume transaction systems, reporting-heavy applications, complex business processes. Trade-off. CQRS increases complexity and requires careful management of data consistency. There is no universal architecture pattern that works for every application. The right choice depends on business requirements, system complexity, team capability, scalability needs, future evolution. A simple layered architecture may be perfect for one system. A complex enterprise platform may require microservices, event-driven design, or CQRS. Great architects do not choose patterns because they are popular. They choose patterns because they solve real business problems.